Here we are going to look at an important factor which is called as a marine heat wave, that is the blob. So what is this and why it is important, we will be looking at. Basically the climate change what we call is because of the ocean warming, especially in the Arctic region. This is a very crucial one. Here what we are seeing is increased frequency and duration of marine heat waves. So in the ocean we are actually seeing heat waves. So this is responsible for the Arctic warming, and especially the Northeast Pacific marine heat waves or the BOBs are the one which changes the atmospheric circulation patterns, which leads to reduction in low level cloud fraction. So we have reduced latent heat loss and enhanced solar radiative heat fluxes. So both the things are happening, which leads to increase in the sea surface temperature. So this SST is the most important one. When the sea surface temperature increases, actually we have also seen earlier, the ocean acidification is also being affected, and it also affects the sea ice extent, both its area coverage and the thickness of the ice, both are getting affected because the temperature of the sea surface increases, and this leads to increase in marine heat waves. This is a positive feedback, so which is expected to change the Arctic climate, and we already know the climate change adaptation and mitigation plans are very essential to reduce the heat waves, marine heat waves. So what are marine heat waves? Basically these are defined as a prolonged discrete anomaly warm weather event that can be described by its duration, intensity, rate of evolution and spatial extent. So in order to consider whatever is the temperature change is the one we are actually talking about, the marine temperature or the sea surface temperature changes. So with respect to what and how do we actually define that particular change is a marine heat wave? So we have to consider that it has to last at least for 5 or more days. So that is point number 1. And with the temperature warmer than 19th percentile based on 30-year historical baseline record. So we already know what is the average temperature in the Arctic. So with respect to that, how much it is actually increasing, and that increase has to happen for over a period of 5 days consecutively. So when these two parameters are met, then we say that particular event is a marine heat wave. So marine heat wave can be caused by combination of atmospheric forcing, that is heating, and oceanic condition, that is faster advection or advection of unusually warmer water, because the Pacific also brings in warm water. The temperature anomaly, that is the deviation from the long-term mean, example 3.5 degree above average, is basically considered. So here is a chart which talks about what is a marine heat wave. So we have primary and secondary events. Here if you look at the temperature is, the climatological values are given here. So this is the average temperature that is there. This is the SST, means sea surface temperature, is given in the y-axis, and the days of the year are given in the x-axis. So the temperature slowly increases, but it reaches a heat spike. But then if you look at this is the 0 day, 0 to this is by the 4th day the temperature actually had dropped. So that means even though on the 3rd day the temperature was very high, but the 4th day the temperature dropped. That means it cannot be, or it is not called as a marine heat wave. But in the second shift what happens is the temperature gradually increases, and it actually stays for more than 5 days at a higher temperature. So all the 5 days it is higher than the average temperature of that particular region. So that is where it is called as marine heat wave. So from this particular, this is the starting point and this is the end point. So these many days, like if we calculate here, maybe from roughly from the 9th day to roughly here up to the 16th day, the temperature was higher. So this is what is called as a marine heat wave. So here the temperatures threshold and other values are given. In the accompanying textbook I will explain many of the things in elaborate. So the marine heat waves basically leads to events characterized by prolonged anomaly high sea surface temperatures. So this is the major problem. The Arctic sea ice variability is primarily driven by the atmospheric temperature fluctuations and also by surface albedo. Clouds and water vapor, surface winds and poleward atmospheric and oceanic energy transport all involved in this particular process. similarly, the increase in the greenhouse gas also is driving the Arctic land surface temperatures to higher values. So the Arctic anthropogenic forcing due to aerosol particularly offsets the GHG effect. So what is this offset? Offset means it actually diminishes or removes that, because the aerosol actually protect, and because they are dispersed in the air, they actually block the sun rays reaching the surface. So that is the reason the temperature are controlled by these aerosols. So here is basically what is called the Keeling curve, which we already know. So currently the carbon dioxide concentration in the atmosphere is increasing. So here the values are given from 1979 to 2024 currently till now we had seen that. So starting from 340 or close to 330 in the year 1979, currently we are having close to 420 ppm of carbon dioxide in the gas, and this follows the seasonal pattern. So this is basically measured from the NOAA's ESRL carbon cycle, and this is for the carbon dioxide and this is for the methane. So methane is also gradually increasing in the atmosphere. And what is the global trend we are saying is the global growth rate is actually changing according to the methane's concentration here every year. Some year it goes up, some year it goes down, like that variation is there or fluctuation is there. And here is a map which talks about the temporal and spatial variation of carbon dioxide and methane in the atmosphere. The red ones are actually having the higher values. The pink one or the purple one is having the highest change or the deviation or increase. So here again it is from 2008 to 2024. So in this period, that is in the year 2016, there is a maximum increase of carbon dioxide in the atmosphere. And currently if you look at in 2024 also, we are actually having, see, if you look at the region, this is 90 north is the Arctic region, this is the equator, and this is the South Pole. So if you look at this, in the equator also the temperature, the concentration of carbon dioxide was very high in the year 2016. Similarly, in the Arctic region also the concentration of carbon dioxide was very high, but in rest of the years the differences are little bit different. In fact, in 2009, if you look at here, we have a green color here, whereas the blue color is there in the Arctic region. That means the temperature increase in this particular region was very less compared to the equator, but currently the Arctic region is having higher temperature than the global. So that's what we say in the Arctic amplification. The Arctic region is having a higher temperature with respect to the global average. Similarly, if you look at the methane's pattern, from 2020 onwards, there is an increase till 2023 in the entire planet, so to say. The methane concentration had increased very high, but currently it was somewhat less. But still, if you look at the Arctic region, it is still higher, and similarly near the tropical area also, the concentration of methane is very high. So here is the details about two other gases. One is N2O and another one is carbon monoxide. So here the N2O concentration also is increasing. It is actually in the parts per billion range, and yearly the changes are actually given here. Global rate, from 2000 onwards the amounts are gradually increasing. And with respect to carbon monoxide, it is again represented in parts per billion. So it is actually decreasing, so to say. The carbon monoxide amount in the atmosphere is actually decreasing. And here is the difference which is given here. There are 2 years, like in 2020 there is a higher concentration of N2O, whereas in 2023 there is a maximum concentration of carbon monoxide.